Hello students, welcome to Legacy IAS Academy. In today's video, we are going to discuss about desert landforms, or also sometimes it is called as arid landforms. So in this video, we are going to discuss about such landforms which develop in the desert area, which are formed due to the action of erosion due to movement of several agents of erosion such as wind or air. So let us start and try to first of all understand that what basically we mean by the term desert. So first of all, desert can be in simple terms described as a landscape where the precipitation, that means the rainfall, occurs at a very low level or in a very small amount. And thus, due to this low amount of rainfall, low volume of rainfall that happens in this desert area in annual basis, it gives desert a kind of barren appearance. Not only that, also due to the lack of water, living conditions both for the plant life as well as the animal life are very much hostile in the desert areas, and that is why only such plants and animal can grow there, can live there, which are habituated or which are adapted to such dry and arid conditions. Not only that, even as we discussed, since precipitation is very low in the desert areas, obviously the amount of natural vegetation, the density of natural vegetation will be quite lower, and since there is a lack of natural vegetation, it causes the unprotected surface of desert to be exposed by various agents of erosion, various forces, exogenous forces that are acting on the desert surface, such as the movement of winds, movement of water, and due to this we see a continuous process of denudation that occur in the desert regions. And as we can see, if you look at the entire land surface of the earth, almost 30% of the land surface come under the arid or semi-arid region. To give you a brief idea of the major deserts of the world, so if you look at the largest desert of the world, it is the Sahara Desert, which is situated in the northwestern part of Africa and then extend all the way up to the East Africa. Similarly, in the North America, we have Mojave Desert. We also have Sonoran Desert. In the South America, we have Atacama Desert and the Patagonia Desert. Similarly, in the southern part of Africa, we have Namib and Kalahari Desert. In Arabian Peninsula, the entire area is kind of desert region, arid region called as Arabian Desert. India, we have Thar Desert in the northwestern part of India, extending all the way to Pakistan. And then we have cold desert in the Central Asian region where temperature is very less. That is the Central Asian Desert and the Gobi Desert. And then in China also we have a Taklamakan Desert. Similarly, we also have desert in Australia, which is known by the name of Great Victorian Deserts, or also called as Western Coast of Western Australian Desert. So these are some of the major desert regions of the world. Now, depending on what kind of surface we find in desert, we can divide the desert area into three types of desert. So first, such kind of desert which we commonly associate with whenever we talk about, whenever we think about desert, the kind of picture that comes into our mind, generally it is Arak kind of desert. And Arak is Arabic word which basically means sand, and thus Arak desert refers to such kind of desert where we have a sea of sand. A large area of the particular landmass is covered by the sand deposits or sandy sediments. For example, the Arabian Desert in Arabia, the Sahara Desert in Africa, and Namib Desert in Namibia are the best example of the large-scale arid desert. Not in that, even if you look at the Thar Desert, a large part of Thar Desert is an example of arid desert. In simple terms, thus we can say that arid desert are nothing but vast stretches of undulating sand dunes that continuously moves in the direction of the wind. So that is the first kind of desert. The other kind of desert surface which we come across around the world is what we call as rig desert. Now rig again is an Arabic word which basically means stone. Such kind of deserts are also called as Gibber plains in the Australian region. And this is an example of desert pavement. As you can see from this particular picture here, the entire pavement looks like made up of small to large scale rocky fragments, and thus it can be defined as the extensive sheets of angular pebbles and gravels. Now, why angular? Because the wind direction keeps on shifting in the desert areas, and depending on from what direction wind is moving, erosion happens mainly in that direction. And suppose if wind direction is changing continuously, then there will be erosion of these pebbles, erosion of these rock surface from 2-3 directions, and thus we'll have a pointed kind of pebble that will develop on the desert surface. And such huge accumulation of angular pebbles and gravel is what make up the rig kind of desert or rig type of desert. The third important type of desert that we see across the world is called as Hamada Desert. Hamada again is an Arabic word which means rocky landmass or rocky desert. This particular kind of desert is basically cleared of sand and dust because the wind velocity is very higher. The wind is moving at very high speed, and that is why all the small sediments are there that are basically removed from this kind of desert regions, and thus only rock particles remain there, rock fragments remain there. Also, we can say that in the particular kind of desert, you'll have the bedrock that is continuous, that is exposed, and thus cemented sedimentary material you will see all across this desert region. As you can see from here, this is the bedrock. Due to the movement of the wind, we can see we have continuous erosion that is happening. The bedrocks are disintegrated, and all these rocks, as you can see, large size of rocks are there that are kind of covering the desert surface. So we can say that it is a kind of exposed rocks which are thoroughly smoothened, polished, and highly striped. Again, why it is smooth and polished? Same reason is there, because the wind is moving continuously, and due to movement of wind, as it moves over these rocky surfaces, due to erosion, the surface becomes much more smoother, surface becomes much more polished in nature. So this is the third kind of desert which we call as a Hamada desert. So Arid desert, Rig desert, and Hamada desert. Now, before understanding that what kind of erosional landform we can see developing in the desert area, we have to understand that what exactly is the process that causes development of different types of landform. And such kind of process is called as aeolian process in the desert. So three major processes are there through which landform development is observed in the desert area. The first such process is called as abrasion. Now, abrasion is simply what happens if suppose there are large number of sediments are there that is present in the desert area, which is of various different sizes, and when the wind is moving over the desert area, these wind carry these particles along with themselves, and thus when these sediments, when these small to large size particles, when collide with any other landmass, collide with any surface, such as suppose that this is a large piece of stone slab or rock slab is there, when these surfaces are continuously bombarded by these particles, small sized particles, then that causes disintegration of this slab, that causes change in the features of this slab, which is called as abrasion. Second process is what we can call as deflation. Deflation is nothing but sometimes unconsolidated sediments are blown away in the desert area, creating a kind of a small depression. And as this depression is created, more and more sediment particles get entrapped in this. And due to eddy effect, they keeps on rotating around this small depression. And thus, in due course of time, it becomes larger and larger in size. Sometimes, if rainfall happens, or if water table is sufficiently not water table is nearby the surface, then this depression is sometimes filled up by water also, and that leads to development of oasis, which becomes a major part or major place of economic activity as well as social activity in the desert areas, and also attract a lot of settlers from around the desert areas. The third kind of aeolian process that we see in desert is what we can call as attrition. Attrition is when the sediments and the small rock fragments of various size, when they are colliding with each other, that also causes them to break away into smaller fragment, much smaller fragment, and thus disintegration of the sediment into much smaller fragment due to continuous collision with each other is what we can call as attrition. So it is by the process of abrasion, deflation, and attrition that we see development of several different landforms in the desert region. So let us try to understand that what are each of these individual landforms. Not only that, we also have to understand that when these particles are moving, there are transportation that is going on in the desert area. These particles are being transported, and transportation happens in various manner. So for example, if sediment size or the particles are very finer in size, in that case they can simply be moving in the atmosphere along with the wind, and they remain kind of suspended in the air or suspended in the atmosphere. So such kind of movement of sediment and particles are called as suspension movement. Similarly, if the rock fragments, pebbles are much more bigger in size, they cannot fly in the air, they cannot fly in the atmosphere, and thus they are dragged by the wind on the surface. So such kind of movement is what we can call as creep. And in between suspension and creep, if the sediment size or the particle size is relatively in between, then they are carried by the air, carried by the moving wind, and kind of thrown from one place to another place, and that is something that we can call as saltation. So depending on what kind of the sediment is there, what is the size of sediment, we can have suspension, saltation, and the creep movement in the desert areas. Now, due to the combined effect of the aeolian process as well as aeolian transportation that happens in the desert area, we see development of several major landforms. So the first important landforms we have to talk about today is what we can call as vent defects. As you can see from this picture here, this is a example of vent defects. In simple term, ventifacts are nothing but pebbles which are developed, which have on such kind of pebbles where the face has been carved out by sand blasting. What is sand blasting? Sand blasting is simply suppose a rock structure is there, or you have a big rock slab is there, and when they are continuously bombarded by the sediments carried by the winds, then this act of this sediment to basically erode these rock slab is what we can call as sand blasting. So due to the continuous sand blasting of pebbles, the shape of the pebbles changes, and also we see polishing of the surface of the pebble depending on from which direction the wind is blowing. So they resemble kind of Brazil nuts. The shape of these pebbles are called resemble kind of Brazil nuts, and many times they have flat face with the sharp edges, and sometimes instead of having two edges, if the wind is continuously changing its direction, we have three wind faceted surface also we see on such ventifacts, and in that case it is called as dry canton. So in simple terms, ventifacts refer to faceted pebbles that has been faceted by the sand blasting. It have flat face, sharp edges, and sometimes with three wind faceted surface we have development of dry canton rather than ventifacts. The second important landform that we see in desert areas are called as yardans. Yardans can be defined as elongated ridge or remnant rock feature that has been sculpted by abrasive wind erosion. Abrasion is a process by which we see the disintegration, by which we see the denudation on the desert surface or rock surface, that is due to the movement of wind. So due to strong, steady prevailing winds that is always moving from the same direction. For example, if you look at this picture here, we can see how the yardans have been shaped. As we can see in the yardans, you have the vertical band of hard and soft rock. That means here where erosion is more extensive, you can understand earlier there must be some kind of softer rock, and this is the place where erosion is less extensive. That means this is the hard rock. Again, this is the hard rock. So we have the alternate arrangement of hard and soft rocks, due to which what happens when the wind moves, the softer rocks are eroded at faster rates and a kind of trough-like feature, a small valley depression-like feature develops here. On the other hand, the hard rocks are eroded at a lower extent, at a lesser speed, and thus they resemble a cliff-like feature. So this cliff-like feature that develops in the desert area, that is in between which we have a trough-like regions. So that is what we can call as yardans. This is the actual picture of yardans. As you can see, this is the vertical rock that is much more harder. This is again a vertical rock that is much more harder, and in between these rocks you can see a kind of area which has been completely eroded away due to the action of wind. A feature that is very similar to our Yardan in structure is what we call as Jugan. The only difference between Yardan and Jugan is in Yardans what happens, we have the arrangement of hard and soft rock in a vertical direction. That means here we have hard rock, here we have soft rock, this is hard rock. This is what you can call as Yardans. On the other hand, in Jugans, what happens? We have a horizontal bands of hard and soft rocks. That means on the upper surface we have hard rock, then again here we have the soft rock, and again in the bottom we have hard rock like a structure. So this kind of element of the hard and soft rocks lead to development of Jugan. This is we can also define simply as a table like landmass, that we can call it tabular landmass, with weird looking ridges and furrow kind of landscape. As you can see here also, the area that is what we can say is made up of less resistant rocks, they are eroded at a faster rate, and that is why due to continuous erosion we have furrow like a structure that develops here. Here we can see this is the harder rocks, so it is eroded at a slower rate, while this at the bottom side we have softer rocks that is eroded at much faster rate, and this leads to development of Jugan. The height of general Jugans are between 3 meter to 30 meters in general if you see Jugans all across the world. This is the actual picture you can see of Jugan. Here you can see the upper part of Jugan is made up of harder rocks. That is why it has not been eroded significantly. As you can see, this is extending more and more in the outward direction because the hard rocks. While the rocks that are present at the lower surface, you can see they are continuously receding in the backward direction because this is your softer rocks, and that is why the rate of erosion is quite higher. Then again below that we can see the rocks are protruding in the outward direction because these are made up of hard rocks, and again we can see here these are more protruding in the outer direction because these are made up of much more harder rocks. So that is why this kind of alternate arrangement of different nature of rock is responsible for the development and formation of Jugan in the desert region. The next most important landform which we have talked about is what is referred as Inselberg. This is the actual picture of Inselberg. So by picture, of course, you can understand that what kind of landmass it is. But if we have to use a word, we can say simply that Inselberg are kind of isolated residual hills that is rising abruptly from the ground level. As you can see all around this hill area, the ground level is kind of flat land is there, and from this flat land suddenly you have this sudden steep rise of this kind of landmass, this kind of mountain, this kind of hill. It has very steep slope as clearly visible from the diagram. And also the other important point is that many times we talk about hills, we draw the top of the hill or the peak of the hill as a conical, we'll say. But Inselberg is different because Inselberg has a steep slope, but at the same time it has a kind of rounded top, as we can see from this particular diagram. Many times geologists considered Inselberg as an example of relict feature or residual feature of eroded landmass. Let us try to understand this. Geologists believe that in an earlier point in time there must be a large plateau-like structure in this particular area. And within this plateau-like structure, we have different types of rocks. So maybe it is possible that large part of the plateau is made up of softer rocks. So over a long period of time, due to the movement of wind and water, these soft rocks has been eroded away, but this region which was made up of hard rocks, they have not been eroded, and that is why the plateau has converted into a plain. And here we have the hard rock, and here also we have the plain, and this isolated kind of hill that you see is what we can call as Inselberg. One of the most notable Inselberg what we see is in Australia, that is called as Uluru or Ayers Rock. If you look at the picture of Uluru Ayers Rock, you will see that all across this rock we have a flat landmass that has been completely eroded away due to the movement of wind. But the Uluru and Ayers rock is still standing tall because it is made up of much more harder, much more resistant rock. So that is the example of Inselberg and how Inselberg forms. Now again, a very interesting development of desert area we see is something which we call as mushroom rock, because as you can see the shape of this rock structure looks resembles the shape of mushroom. So mushroom rocks also develop due to the sand blasting effect of the winds and the sediment, the particles that it carries against any projecting rock masses. For example, as you can see, this is a particular rock layer, rock mass, which is made up of harder and softer rocks. So the rocks that are less resistant, they are eroded at a greater rate, and resistant rocks are eroded at a slower rate, as we have discussed before. So when large amount of sand particles, large amount of sediments are continuously being bombarded by the winds, due to this what happens, we have different part of the rocks undergoes erosion at a different rate. And as we know that obviously most of the sediments, if they're heavier in nature, they will flow very closer to the surface. That means if you are going from the surface to the upper part of atmosphere, obviously if I ask you that where will most of the sediments will be there, where will most the particles that will carry the wind will be located, so obviously your answer will be it will be closer to the ground surface. So obviously if suppose you have a uniform structure of rock that is lying in the way of this wind, and if the sediments are more denser here, if the number of sediments are much more higher here the number of sediments are much more lesser. Obviously if I ask you that which part of rock will undergo erosion at a faster rate or to a maximum extent, obviously you will say that it is the lower part of your rock that will be eroded at a much faster level, at a much faster rate. And that is why you can see here the upper part of rock, since here the sediment that is coming at this particular height is very lesser, they are eroded at a lesser rate, and these are eroded at much faster rate, and that is why these are much more thinner in volume, thinner in diameter, while upper part of the rock is much more wider in diameter. And it is due to this region we can say the differential erosion due to the height difference give rise to what we can call as mushroom rock. Also, as we have discussed, it wears down the softer layer leading to formation of irregular edges. Maximum erosion occurs near the bases where friction is the greatest, and that is why we have formation of mushroom rocks. The second last landform which we have talked, which we see in the desert areas, are called as Mesa and Butte topography. If you look at from this particular picture, it is clearly visible. We have this large plateau is there. A part of plateau has been eroded, creating a gap here. And then here we have a large flat shape or tabletop kind of landmass, which we call as mesa, and a small tabletop landmass, a small, we can say, like very similar to Inselberg, we have what we can call as butte. And if butte is also eroded significantly, then it is what leads to development of monument. In simple term, we can also understand it like this, that the larger part which is having this plateau-like structure, this is having flat top structure, elevated structure are called as plateau. A small part of plateau which is kind of separated away due to erosion is called as mesa. If Mesa is eroded significantly again, it converts into butte, and if butte is eroded significantly again, it converts into what we can call as monument. Let us try to understand then what the term Mesa and butte means. So Mesa is a Latin term which means table. Thus, Mesa can be defined as a flat table-like landmass with a very resistant horizontal top layer and very steep sides. This is very important because what happens, the upper part of this mesa is made up of resistant rock, and that is why it undergoes erosion at slower rate, while the lower part of mesa is eroded at much more faster rate because it is made up of softer rocks. The hard stratum on the surface resists denudation, that is erosion, by both wind and water, and this protects the underlying layers of rock from being eroded away. And generally, they develop in the canyon regions. For example, if you go in the Arizona region of the United States of America, you have a lot of such kind of mesa and butte topography is there. Similarly, in the fault blocks where you have faulting, the continental crust is separating apart due to continental divergence. We have a tabletop mountains such as Cape Town in South Africa. We will see such kind of mountains. So continued denudation through the ages may further reduce the mesas into areas so that they become isolated flat top hills, which is called as butte, and the further erosion of butte can lead to development of monuments. If you look at from the far distance, this is a picture taken from Arizona. As you can see, there are large number of such structures are there. If you imagine that millions and millions of years ago, then this entire area would have been one single plateau. But due to the differential rate of erosion of harder and softer rock, a large part of plateau you can see has been continuously denuded away, continuously destroyed, continuously has been eroded away, and here and there the pieces of rocks, the part of the plateau which is made up of hard rocks remain standing there, and that is why you have development of mesa and butte topography. The last landform which we can see that develop in a desert area is what we can call as deflation hollows. If you remember, in the beginning of the session we have talked about a process, aeolian process, that is called as deflation. So in deflation, what happens if the prevailing wind direction is coming from there, for example in desert areas, due to the removal or the blowing away of unconsolidated sediment by this wind, a small depression develops. And as a small depression develops, wind start to move at a much more faster rate through this depression, and thus gradually this depression area and its size, its area keep on continuously expanding. And for example, if you look at the Qattara depression, or the most notable depression that has developed in the Egypt, because the wind are continuously coming from the Mediterranean Sea regions, that is the prevailing northeasterly winds, they have created depression here, and over a long period of time, this depression has been continuously hollowed out. Continuously, a large amount of sand and all these things have been removed away, and thus today it has attained a depth of 122 meter below the sea level. Many times water gets accumulated and collected here, leading to development of oases in the desert areas. So I hope you understood about the important erosional landforms and how do these landforms form in the desert areas. If you liked the video, please hit the like button, share it with your fellow aspirants, as well as subscribe to our channel for more such helpful content. Thank you very much.